Welcome you all for the next session on Introduction to Deep Learning, which will be handled by Mr. Ashok Perumal. I feel glad in introducing our resource person to the gathering. Mr. Ashok Perumal, Technical Consultant, NURA TechNaps, Chennai. He has over 25 plus years of experience in IT industry and excellent exposure to solution proposal, scope management, design, managing construction, testing, implementation, and post-implementation support. He has and web technology engagement successfully with client satisfaction. He has completed digital marketing training from Madras Management Association and hands-on experience in implementation of search engine optimization, on-page and off-page optimization, Google tools, video, blog, and social marketing. Great honor to have you with us today, sir. I would like to request our resource person, Mr. Ashok Perumal, to take over the session.
Okay, thank you. Good morning, everyone. And I will switch off my video. Yes. Yes, am I audible? Hello? Hello? Hello, am I audible?
Am I audible to you, sir?
Hello, you are
Hello,
audible,
everyone. You are able to hear
me?
Audible,
sir.
Okay. Okay, thank you. And I will switch off my video so that you will have a quality voice.
Yes, sir.
And okay. I will go and share my presentation. Please hold on.
Yes, sir, you are audible to us, sir.
Yes, please.
Yes, sir. Audible to us, sir. You are audible to us.
Okay. I think you are able to see my first screen, Introduction to Deep Learning.
I can hear you, sir.
Okay. Yes, sir. Okay. In case if you have any issues, let me know so that I will move from another place and I'll try to handle the session. Okay. Thank you. The agenda for this session is, even though you have a data science introduction 2 days before, I just have a time briefly spent on 10 to 15 minutes or 20 minutes on AI/ML and what is DL, that is data deep learning, and a brief update on machine learning. Then we will go on to the deep learning. In deep learning, we will go to the deep learning networks. And finally, we will go on the deep learning frameworks and the limitations of deep learning. Finally, we will have the recap. If you have a time, I will show an example of a trained deep learning network from what is available on the web, so that it's easy for everyone to understand. Okay. So I think it will take only 5 minutes in the last 5 minutes. I think even though I have a lot of slides, it won't take more time for me to go ahead of this. Okay, I will move on to this prerequisites for deep learning. Okay, if you are interested to learn deep learning, what is the prerequisite? Okay, you need to have an interest in deep learning or learning new things. Okay. And knowledge of one programming language is enough. For example, there are a lot of, actually, there is no need to be familiarized on in the grade of 1 to 10. People say that if you have 8 or 9, then you are good in the programming. But here, you understand the programming languages like what is an assignment statement, what is a conditional statement, what is a loops, what is the nested loops and other things, so that you can implement on your own very easily. Okay, so that is one of the prerequisites. And the next one is commitment to learn. There are a lot of YouTube is available, a lot of material is available on the net. You can learn on your own. It is easy with somebody's guidance. Okay, and no need to join anywhere else. It is a procedural way of learning things. So that will take you to the deep learning. And the next one is little knowledge in machine language is enough. The reason is when you are trying to learn Java And if you're already familiar with C++ in the scale of 1 to 10, if you're 9 in C++, it is very difficult for you to learn Java because you will correlate too many things and get confused. Getting confused is good. It will lead to a good solution. But to learn things very fast, a little knowledge on machine learning is enough. If you have a deep knowledge, then you will ask why this, why that, why unsupervised learning, something like that. Okay, it will go on, keep on happening. So these are all some of the prerequisites for deep learning. Hope I am audible, and if you have any issues, please someone alert me so that I will try to switch on the another network. Okay. So I am moving on to the next slide. Why you need to learn deep learning. So the thing is, it is redefining the way of computing is being used to solve our problems. And the next one is many startups involved in building AI applications. And the next one, some of the existing jobs will vanish or change from most attractive jobs or leading to deep learning. And the fast growing technology being adopted, for fastest growing technologies being adopted across disciplines. For example, deep learning is already into our part of our life. The recommendation engines, whatever you see, even in your mobile, whenever you receive a photograph or in a WhatsApp, it is automatically stored in the images folder. Okay, how it recognizes it is an image folder, and some algorithm is there which understands that to do something. Previously, what happens? It will download it to a download folder, and then we will personally move. In mobile, it is not like that. So what I'm trying to say is like deep learning is the way of living after 10 years or 15 years, and the quality of life is going to increase. And some challenging jobs. Suppose, for example, if you have a job A now, and it will be replaced with job X plus some bells and whistles. Okay. So that is the way we are moving to the deep learning. That's why we need to learn deep learning also. Okay, I'm moving on to the next one. Here we will see briefly what is AI, ML, and DL. Okay, artificial intelligence, machine learning, and deep learning. In the artificial intelligence is the capability of a machine to imitate an intelligent human behavior. Here they say that it is an intelligent human behavior. A human can do too many things at a one view. For example, if I'm looking at the road, I can look 10 different things, okay? So the artificial intelligence is also imitating or mimicking the intelligent behavior of a human being. For example, AI is accomplished by studying how human brain thinks, learns, decides, and work while trying to solve the problem. Okay. And finally, the results will be used as an input for developing an intelligent software system like speed violation and others. Suppose if a car goes on a particular speed, 60 kilometers, it is not a violation. If it goes on 80 kilometer on a particular road where the speed limit is 70 kilometers only, then that is a violation. So why can't we do this by the existing technologies? So to control the car speed limit, human to monitor and note down the details of the car. Do you think it's possible in Chennai or any cities in all over the world? It is not possible. Even if you have thousands of people, you will miss someone. Okay, and the number reading may be wrong. But what we can do is we can do auto monitoring with the help of a camera, and we can who exits the violation. For example, monitoring use camera and machines to capture the speed violations and other traffic rules. For example, you can fix the cameras. Okay, the cameras will read the speed, and at the same time it captures the images also. And it continuously captures the image, and it helps for theft and other crime related things also. Okay. And for example, this is one of the ticket being produced in Kerala. Kerala traffic team is using this. See, the particular person notice is issued in a particular location on a so-and-so time. His speed limit was 80 kilometers, and here for the personalization purpose, the data is masked. Okay, so this can be done for n number of millions and millions of users at any single point of time without any human intervention. Do you think it's possible with human? It is. It's maybe a tedious task to achieve this, but machines can do this. So that is why we need an artificial intelligence, which helps not only in this area. There are too many things. Okay, too many things, and the artificial. What is the subsets of artificial intelligence? For example, artificial intelligence is capable to imitate the intelligent behavior of the human. And you see here, artificial intelligence as a subcomponent of machine learning, and machine learning as a subcomponent and deep learning. Okay, machine learning is a tool through which overall, and now if somebody says I'm developing an artificial intelligence application, it should have been used machine learning, or in few cases it should have been used deep learning. Okay. So that is the subsets of artificial intelligence is machine learning and deep learning. Even though you are aware of this, but I'm trying to brief this before going to the next one. Okay. Otherwise, if I say machine learning, then there will be some gap in understanding. Okay. So where data science fits in? Here you see artificial. Here you see we have artificial intelligence, and you have machine learning. And data science is overlapping all these three. And you have a big data. Big data means after the smartphone usage across the world, the data is, we have more and more data actually being generated on every minute, every second. Okay. So the processing of data uses the big data, and I'm not going to get into any one of this topic. Any one of the topic, if I get into that, I need to speak for 10 to 15 minutes or even 30 minutes. Okay. So how the high level picture at 2000 feet level, this is what artificial intelligence, machine learning, and deep learning, how data science fits in. Okay. So that's why the artificial intelligence. And some of the applications of artificial intelligence is speech recognition, understanding of neural language, natural language. For example, understanding the text and the spoken words, it can be possible. Image recognition, self-driving cars, smart assistants. Smart assistant means Google provides smart assistants, no? The same thing. Proactive health management. For example, if before something happens, actually, we give alert to the family doctor that Ashok is having some following problems based on the readings captured on every day for the last 15 days. And the same reading will be forwarded to my family doctor so that he can call me and suggest some medicines. In case if he call me for a physical check, I can go for that. For example, you see that on Kannada superstar has passed away 2 months back. If we have the proactive healthcare management system, we should have saved him, because people are saying if he should have reached to 1 or 2 hours before, he should have been saved. So it is possible actually in many cases. That is called a proactive healthcare management, but it will take at least 5 to 10 years to reach that level actually. Because healthcare management implementation is very risky, and it plays on the life of the human being. Okay. Similarly, for manufacturing of robots now play a vital role in doing operations and everything. Okay. And manufacturing robots, food industry is playing a key role in this robots. If you are a YouTube lover, you can watch the food channel, and there are a lot of food channels with automated machines. Okay. And disease mapping is also possible, and lot others, the applications of artificial intelligence. When we develop this, even though these are all the applications, when I go through machine learning and deep learning, I will still use the same applications, because artificial intelligence is a global at the high level, okay? The machine learning and deep learning uses using the tools and statistical methods and algorithms and models, these applications will be developed. Okay, don't get confused on this. Okay, any questions before I move on to this? Okay, I will move on to the next machine learning. What is machine learning? Machine learning is a type of an artificial intelligence that allows software applications to become more accurate at predicting outcome without being explicitly programmed to do so. The machine learning algorithm uses historical data as an input to predict an output. See what happens actually here, we collect the historical data, and based on the historical data, the new output values are being delivered. For example, we have an ordinary system, and with an artificial intelligence system, the machine learning, what exactly it does, it predicts the value, initial value, okay? And based on the more data we receive, it learns, okay? And similarly, for example, what happened, and the machine learning also keep on improving, which is like a continuous integration kind of a thing. It keeps on learns and improve with the data, new data coming in, okay? This is also possible in deep learning, but machine learning has some challenges. That's why it leads to deep learning, okay? So here you take an example of iris setosa, okay? Here we give petal and sepal as an input, and based on that, it will identify the color and what is the plant type. For example, if you give the sepal length and sepal width and petal length and petal width, it will identify what type of flower it is. Similarly, here, that is what I'm saying, okay? It is an historical data as input to predict the new outcome, new output value. See, to predict an output value, we give what the existing data is available, and it has to be monitored. Human intervention is required in this machine learning, okay? I'm moving on to the next one. What are the types of machine learning? It's just supervised learning and unsupervised learning and reinforcement learning. Supervised learning, we uses classification and regression models, which is a fraud detection, email spam, diagnostic, image classification. Whereas in regression, we have a risk assessment, score prediction, and in unsupervised, we have text mining and face recognition and etc. etc. And reinforcement is a gaming factor, financial sector, manufacturing, inventory management, and robot. We will go into that briefly on looking into that. What is supervised learning? Supervised learning is where you give an input X and output variable Y, and using an algorithm learn the mapping functions. For example, you have a training the data. You have a training the data, and learning algorithm is there, and the model is it is fed into the model. And once you fed into the model, the test data is captured, and the accuracy is being monitored. It's just like similarly what I told in the machine language introduction section. Okay, here it plays a training and testing, and this activity keeps on fine tuning. Okay, and the next one is supervised learning. Supervised learning is the training of the model using information that is here in this previous one. Some supervision is required. Okay. We call it as the labeled data and unlabeled data. Labeled data means when you say give an input as weights and heights of a person, the weight and height is the labeled data. Based on the weight and height, we can find the obesity of the person. Okay, so that is called labeled data. Whereas an unsupervised learning is training of the model using that. This model can be used for cluster approach. For example, what is a cluster approach? When the input is sent on a scattered, actually you have a pink color, green color, and blue color. Okay, and when it's sent back, it is kind of, in a college also you can see the informal groups. For example, if somebody is from Kerala, they form one group. If somebody is from Madurai and down Madurai, then they'll form one group. If somebody is from Chennai, they'll form another group, which is like this, okay? So which is called clustering of use the cluster the input data on the basis of the statistical probabilities. Here the supervised learning, which is on particular, how it is being calculated. For example, the blue color will have some weightage in the pixel, okay? And green color will have some weightage. Similarly, for pink color will have some weightage. Based on that weightage, it will calculate. On the first iteration, there is a possibility that it may be accurate for 50 to 60%, okay? So if the iteration goes continuously, then it will be a final one, okay? And 100% predictability is not possible, which is 95 to 98% or 99% is possible, okay? The next one is reinforcement learning. Reinforcement learning is by interacting with the space of an environment. The reinforcement learning, we have used that one of the application is inventory management. In a manufacturing shop, based on the final finished good product, if it is still in the warehouse, then it automatically changes the reorder level, okay? So that is called reinforcement learning. That's why that application what we have given, suppose for example, I'll go to this slide. Here I have used in the reinforcement learning inventory management, okay? What inventory management, the reinforcement is doing is, you have in a manufacturing setup, you will have a work in progress, stores, and then the final finished products, okay? You are supposed to have a finished products of 200, then you can order a quantity of 1000. If the finished product is 800, then the order quantity will automatically reduce. So which is a learning, okay? It can't blindly go and order continuously whatever the level, okay? So that is called reinforcement learning. So what is reinforcement learning here? Actually, example is someone will act as an agent and the environment teaches him, okay? For example, the environment here is fire and water. The agent will first go and touch that fire and it will say it is too hot, and he thinks that whenever a burning things, if you touch, you need to go with some protection, okay? When he goes and touches the water, then it is safe. So he learns that it is a negative, and when he touches the water, it is a positive. Similarly, for example, we can say too many things, okay? For example, when a kid, take an example of real life example. When a kid says, 1 year kid says his father that Poda or something, okay? Then we'll say how cute she is and how cute he is, something like that. After 3 years, if the boy goes to the school and if he says the same thing to the teacher, and teacher will scold him and call his father and mother, and he'll say he's using some bad words, okay? But now the kid learns that where to use this word and where not to use this word. That is called which is called a kind of a reinforcement learning, okay? Reinforcement learning is keep on updating what you need to do in the future. That is why I used the inventory example also, okay? And the challenges of machine learning. Actually, the machine learning, whatever we have discussed, are not useful of working on a high dimensional data. That is where we have a large number of inputs and outputs. Large number of inputs mean millions and millions of data on heights and weight. It's not like that, okay? I will tell you actually in a few minutes. Cannot solve crucial AI problems like natural language processing and image recognition. The limits of machine learning is so and so. And when you go into that, one of the biggest challenges traditional machine language models is a process called a feature extraction. Okay, it is one of the challenges. Feature extraction is not that much easy. Okay, and for complex problems such as object recognition or handwriting recognition, this is a huge challenge. What is a feature extraction? Suppose, I think you are familiar with whenever you take a mobile, actually in a mobile camera or in a digital camera, whenever you take a snapshot, it is stored on a pixel format, okay? Even though it is 252 into 252 length and breadth, it is stored on a pixel format, okay? So you give actually giving a height and weight of 1 million record and 1,000 images fed into 252 into 252 pixels and doing an analysis on that is complex. That's what I am trying to say here. Are not useful for a high dimensional data. That is where we have a large number of inputs and outputs. That's what we are saying, okay? The machine learning can't handle that actually with that existing approaches, models, and everything, okay? So it is having some challenges. That's why that is called a high dimensional data. You need to understand the limitations, we can call it as limitations or challenges, okay? But similarly, in the machine learning, okay, here you see this prediction is not that much easy. You need to learn actually. For example, 0 can be written by a person in a different format. 10 persons will write 10 different format, but it is easy for a human being to recognize, not for a machine. Okay, so to give, it's possible for a machine to recognize, but we need to give different type of inputs, and it will learn, and it will finally come out with the feature extraction. Okay, feature extraction is the output, final output objects. Okay, and for example, if you have a cat or a dog. If you give 1 or 2 images or 10 images, it's not going to solve the problem, okay? If a cat sitting on a cardboard box, and if you want to find the position and the look and feel and is completely different, okay? So that's why these are some challenges in machine learning which we can't solve this, okay? So how to overcome these challenges of machine learning is deep learning. The finally rescue to overcome these challenges is deep learning. Okay, so we are getting into the topic. Actually, I think I have taken some 25 minutes. Sorry for that, and we'll move on to deep learning. Okay. Any questions before that? I think I can go ahead with the deep learning and finally take questions. Why deep learning? Okay, process huge amount of data. Just now I told you, the dimensional data, structured and data, unstructured data. It is possible, and perform complex algorithms. Machine learning algorithms cannot perform complex operations. To do that, we need a deep learning algorithms. Okay. To achieve the best performance with a large amount of data, actually, to get the best output, actually desired output with a large amount of data, deep learning is the best model. That's what I explained for the last 10-15 minutes. Okay, and the feature extraction, the machine learning algorithm extract patterns based on the label sample data. With deep learning, take a large volume of data as input and analyze the input to extract the features out of an object and identifies the similar object. Whereas deep learning, we give the input, it will identify and separate the objects like a clustering, I told you. It will separate the objects and keep it. And it won't say that it is a cat and it is a dog, okay? It will give 0 or 1 or some classified parameters. If it is a number to be identified, then it will be 0 to 10. but it will say 0 means 0, 1 means 1. Actually, that is the way it is being identified. For example, if the output is comma 0 means it is cat, 1 means it is a dog. Okay. I will move on to the next one. The focus areas of deep learning. Similarly, I told you, some of the applications, it's a text-speech, image recognition, human behavior identity, and abuse and fraud. Why the abuse and fraud comes under the deep learning? For example, everyone in this session may be using email for the last 10-15 years, okay? And you see the type of fraud mails coming, the pattern has changed. Okay, you can't handle with some certain parameters. Then you need to know what are all the bad words actually, what are the threat words and abusing words where you can see. For 10 years back, they will say you have won a lottery. And if you click on that link, they will ask for some money. Once you pay some money, they will escape. Now it is different. I have a father and he is sick. He has $10,000 million or $1 billion, etc., etc. You send that money and we'll live together, something like that. Okay, it is kind of a thing. And nowadays there are different ways of providing link and abusing it. So there is no predefined format of way of. That's why it comes under the deep learning area. You can do this in machine learning also. The accuracy may reduce. That's what we are saying. So it is divided into deduction category, where it is text-speech, where we deduct actually, and the prediction. Astrology is one of the predictions actually areas, and astrology plays a key role. Actually in MIT in US, actually MIT University. The future predictions, the students are using deep learning to predict the futures actually, okay? Maybe interesting, and you can read the article which is available on the net. So that's that level of, and recommendation engine. For example, I may have, Ashok may have a different taste actually, may watch channels, okay, in YouTube. And my recommendations are different. And my wife is not going to get the same recommendations, okay? Her taste may be different, okay? Spiritual and other things. I may be interested in political debates and other information. So that's why it is a recommendation. Recommendations change from person to person. Even my close friend won't get the same recommendations, okay? It is based on the behavior and things actually. Even this individual behavior is similar concepts, okay? And the final one is generation. The last one of deep learning is playing a critical role in creating an art also, okay? If you say I want a natural scene with so-and-so, then it is possible. And the music actually, you can compose the music. Text. I think the people in South India or in South India may know that there is one famous poet called Vairamuthu, and his son is Madan Kargi. Okay, he is an engineering graduate, and he used deep learning to come up with some kind of a lyrics. Okay, when he used one of the lyrics actually for the deep learning, as the model has given some. The ladies that hair is there, no? It says that as it is like a train carriage, okay? A train compartments. Actually, it is kind of a lengthy, no? So the way in which the things are changing after 20 years or 15 years, the complete way may change, okay? So it is already into our life. Similarly, the text generation and other things are being. And design is also possible, designing new things. Okay, these are all the focus areas of deep learning. Where to consider deep learning? Actually, can we use deep learning in everywhere? Where there is no deterministic problem. Example, a recognition of a 3D object from a given scene. given image, handwriting recognition, and speech recognition. For example, if 1 lakh inputs you are giving, you can't write a code for a Ashok will write A like this. Hema will write a code like this, and Hariharan will write a code like this, A like this. I can't keep on writing this, okay? So there is no determined solution for this, like we have interest calculation, etc., and other mathematical problems. Individual specification or time-dependent solution. Time-dependent. Example: recommendation of a targeted advertisement. Just now I told you. Okay. Prediction based on the past and existing patterns. Example: share prices. For example, during festival times, few shares will go up. If the rain, if we have a normal rain, definitely the stock market will have a big impact on the FMGC companies, fast-moving consumer goods like HUL, Britannia, ITC, and etc. So these are all. It is not. See, what I'm saying is, the prices will go up, but we need to predict on the environment, and based on the environment, you can suggest for today what are the stocks you can purchase for the next few months. So that is called stock predictions. Okay, prediction based on past and existing patterns. You have the past data and you have an existing pattern. Existing pattern is you have a normal rain. Then you can plan for buying these companies. During festival times, the Hyperbolic time, you can buy these following stocks, okay? Like textile stocks. During Shankranti time, what you need to buy? Something like that, okay? And the next one is problem do not have a fixed solution. In the previous one also, the prediction of past and existing data. For example, today one of the stocks listed in the stock exchange is data patterns. Data patterns is focusing on the defense sector, okay? In the last 15 days, if you watch, defense sector shares have some ups and downs, depending on this company. So that is called a prediction. Whenever a new company with a high profile and a quality company is entering into the stock market, then you can predict that these are all the following stocks you need to watch. And if their metrics are being good, then you can invest on this, okay? That is possible. And the problems do not have a fixed solution. For example, spam email, financial frauds, IT security, and everything. So the IT security is one of the area people keep saying for the last 20, 30 years, okay? Still, they are not able to solve. Even the big companies are facing this problem, okay? So that is the reason why where to consider is, and we have many things. Whatever I told is few things, okay? So I am giving an examples of this, okay? The myths of deep learning. There may be some concerns of deep learning, or people may think deep learning is not able to replace humans. In few places, it will replace human, wherever the food industry, the washing, and picking up the rotten tomatoes, picking up the rotten mangoes. It will always pick, actually. It will go and pick, actually, based on the imaging, okay? And that jobs will go off, but it will introduce a new jobs, okay? Packaging and other areas. Still some interesting jobs are there. AI has already taken over few jobs like food industry. Interesting jobs will be created by. What is that? Sorry. I think it's not for me. So, okay. Human will think smarter and innovate more. For example, this is for the, one of the example is for medicine field, okay. There are a lot of preventive medical care is going on. So definitely the doctor will see, everyone has to be smarter. Unless if you are smarter, if you are not smarter, the machine will take over you. Okay, it's not like a Terminator movie. That is an extraordinary thing. It may take 1,000 years to reach that level. But that movie itself was released 30-35 years back. Okay, but definitely in the coming years, humans need to be smarter to manage these missions. Okay, the chatbots. Previously, whenever you raise a query in the frequently asked questions, it will be answered by a individual. Now it is answered by a machine, actually. Okay, robot. So these are all some of the areas. Unless until you are not smarter, then you will be you need to look for another. You will be an ideal. Okay, so that's why it says. And AL deep will create new, better, and smarter jobs. That's what we say. Okay, and others. It is not going to lose the job, but it will create a job in a different format. Okay, suppose if you have 1,000 people, and it close to around 900 jobs are going to be there, but they are going to do a different job. Okay, it is not the same job what they know they are going to do. For example, in a security, actually in a weighing machine, in a mains. Okay, take a case of a mains. There is a weighing machine. Based on the weighing machine, the loaded trucks will be moved out of the campus. If it is automated, if you have a three persons taking care of this particular area, definitely will have a one person is required. The two persons will be replaced in a different format. Okay, so that is why we are saying machine learning, actually artificial intelligence, machine learning, and deep learning leads to smarter jobs. Okay. The next one is why there are too much of discussions on deep learning now. As I told you in the previously, because that is based on the data what we have, and before that we do not have a processing capability to process large amount of data. Our CPU actually processing is not that much enough to handle that. That's why we have a GPU, graphical user interfaces. Okay, and based on the large amount of data, the deep learning has evolved from the start of smartphones and use of internets. Okay, so that's why it's called the amount of labeled data. Traditional algorithm uses the accuracy at the lower level, and a smaller neural network uses at this high level, and medium neural network and large neural network, that is deep learning, gives a high percent of accuracy. Okay, how it is possible? Because of the amount of data you fed into the system, and it gives clearly that 90%, 98% accuracy. Okay. Next, we move on to the deep learning core concept called neural network. How deep learning gives that delivers the output. Okay, which is called key component as neural network. Okay. What is a if you see that human biological neural network, deep learning is based on the functions of the human brain. Let us understand how does the biological neural network looks like. See, this is a part of a neuron, where exactly it has a dendroid, cell nucleus, which is a cell nucleus, which is a decision maker, axon, which is a tentacles like is an axon, and synapses. Okay. So then, neural network or artificial neural network is designed based on the human brain, consists of billions of small cells called neurons. So our human brain consists of billions of neurons. Okay, each synapses is connected to a neuron, and ANS try to simulate a human brain. The major part of this particular neuron is a nucleus, and all nucleus are interconnected each other. Just I am giving an example. Okay, don't try to. If you are not able to understand, it is okay. But what I am trying to say is like you will keep hearing this when you go on to that. That's why I told you in the beginning itself. If you have interest in deep learning network, and there are a lot of already pre-trained models are available, you can slowly learn and you can come back to this basics actually also. But this is what I am trying to give an high level. The next one is artificial neural network. See, you give a input. For example, I told you, now you have an image. the image has converted into a pixel, and it has x1, x2, xn, and you have a weights associated to it. X1 and weights are being multiplied, and it is fed into the neuron, which is called the key of the neuron, and the output is predicted by an predictor. Okay, so let us see how these two are biological and artificial neurons maps together. Okay, here the dendroids like this one, this is the places where we get different inputs. Similarly, we have given the inputs, so that is inputs. The cell nucleus, which is called the cell nucleus, which is called a node. Okay, this is called node. Okay, and synapses is the weights. This is the weights. Okay, this is the weights, and axon is an output, which gives an output. Okay, so this is the way the the neural network is designed. Actually, what we have, each model is designed. Okay, and the next one, what is a neural network? So the first step is the process of calculating weighted sums of the input. Okay. Hereafter you can keep watching this. Okay. So here you have an input. You have an input 1 to x actually. After 4 or 5 slides, it will be more clear. And we have a weights 1, 2, 3, which is the random numbers, or depending on some conditions, you can assign numbers, but better to go for random numbers. And standard bias is added, and which is summed up, which is called a transfer function. Okay. And the next one is the step 2. This is what we have seen just now. Okay. And the step 2 is the activation function. Activation function is the one. The activation function is the weighted sum of inputs, and the bias is, the activation function decides what is the desired output, whether it is a cat or a dog or anything. Okay. So it is a binary output, or it may be more than a binary output also. If it is a numbers, it is 1 to 10, 0 to 9. And if it is a dog or a cat, then it is, if it is a shape, circle or something, then it is, the activation function decides, which is, if it is not, actually, we will move on to the next one. What is an activation function? The activation function takes the weighted sum of the inputs with plus the bias as the input function and decides whether it should be fired or not. The activation function is the one which decides whether it is whether we can go to the output or not. If it is not, then it will go on the back side, and it will go and fine tune the algorithms. Okay, fine tune it. For example, how our brain works. You look into the different things, and you won't say, suppose if your professor asks, or if your somebody asks question, you won't say the answer immediately. Okay, you take at least 3 or 4 seconds, or even in case you may take 10 to 15 seconds. Okay, you will ask for give me 30 seconds, sir. Similarly, that the activation function decides whether you can fire the output or not. If it is firing, then it will be an accurate, some level of accuracy. Okay, and there are types of activation function, which is called as sigmoid function, threshold function, ReLU function, and hyperbolic tangent function. Out of this, all these 4, ReLU function plays a key role now. Previously, it is sigmoid, and it is ReLU function. We'll briefly see in the next few slides. Okay. Here, sigmoid function uses the model where we have to predict the probability as an output. It exists between 0 and 1 only. Okay. And 0 and 1 means, I told you, 0 means cat and 1 means dog. Okay. So it's just similar to that. If it is numbers, it will be 0 to 9. Where is the threshold function? Threshold function is based on the activation function. If y is greater than certain value, the function is activated and fired else not. Okay. The y is the output and x is the input. Okay. A ReLU function, it is widely used activation function and gives an output X if X is positive or otherwise it is negative. Okay. And the next one is, these are all some of the formulas kind of a thing you can understand. But when we go into these examples, we can look into this. Okay. A hyperbolic tangent function is similar to sigmoid or similar sigmoid function, but it ranges from -1 to +1. Here it is 0 to 1. That is the difference. Okay. The activation function is the final decider to fire the output. Based on that, it uses the ReLU function. Okay. The working of neural networks, okay, which is a continuation of that. You have inputs, you have associated weights, and we are summing up this. From here, we are summing up this, and bias is added, and activation function decides the model output, which is called a forward propagation, which goes from left to right. Whereas, after training the neural network, it uses the backward propagation to improve the performance of the network. Suppose, for example, what happens, you used it, and the model output is this one, but the actual output is this one, actually, which is expected, this Y. But we got a Y cap, actually. So what happens, you identify the cost function, and back propagation sends back the data to that for relearning, and then it fine tunes it. Okay, how our brain works. There is one optimization called gradient optimization. These are all some of the terminologies people keep throwing bounces on you, but don't get afraid or third. Actually, it is easy to learn. Okay, I will show you in the last 5 minutes. You can understand. Slowly you can learn. Actually, if you have 45 days, 4 or 5 weeks, I think you will be in the scale of 1 to 10. You will be 6 or 7 in deep learning with whatever the knowledge I told in the first slide. Okay, and the cost function. The cost function is the difference between the neural net predicted output and the actual output from which the set of labeled trained data, the least cost value is obtained by making adjustment to the weights and biased iteratively throughout the training process. This process will continue. Okay. The cost function is also there for example, in machine learning, and this is called mean square method. Okay. And we can use other methods also, but commonly used method is mean square, like ReLU. For activation function, we are using ReLU. Similarly, for cost function, we are using mean square methods. Okay. And the next one is, see, this is overall how neural network works. And when a neural network is being delivered, what is an activation function? And when an activation function is there, how it is being keep on training when we are not getting the desired output, and when it reaches the output, it throws the output. Okay, so that's what we have just seen this for the last 10-15 minutes. And you see the working of the neural network. You are sending a cat image, dog image in a different formats. Okay, which is an x1, x2, xn. But for example, you are not sending all the images at a single point of time. We send this image and it will be divided into 1 to n number of pixels. And there is a hidden layer. Okay, hidden layer means this is what just now we saw in the neural network. This hidden layer will send this data, and this data is sent to another hidden layer, and its outputs is dog and cats, which is 0 means dog, 1 means cat. Okay. Here you see you will have a one neuron. This is a neuron, or we call it as a node. Will have a 3 inputs. Means which is a 3 into 3 matrix. Which is x1 will have 3 into 3 matrix and do some calculations, and based on that it will send the value to the next one. So I will explain that. Okay, for example. Here also, here it is another presentation of this is a 1 to n pixel and weights are W1, W2, and we have forward propagation. Actually, you have it is passed on to the hidden layer, and the next hidden layer, the weights are being added, and this is the constant. These weights are being added, and the next hidden layer is being shared. We'll have a more hidden layers, for example, 100 or layers and 200 layers also, okay, to get more outputs, and weights are being added, and finally you will get a desired output. So this is forward propagation, and when we go for a backward propagation, you see these arrows are going back, and to adjusting this, we will use an optimization method called gradient optimization method to adjust. Actually, that is one of the techniques which is used to for a backward propagation. It will changes the weights, actually, weights and bias. You see that adjusting the weights and bias. Previously, what we have used weights and bias. Now we will change the bias, actually, bias and weights. And then we will train this model, and everything is done automatically, okay? No human intervention is required, like what is we do it in the machine learning, okay? And the working of neural network, this is, please keep on, from here onwards, it will be a interesting one, how practically it works. Person A writes a 9 like this, person B writes 9 like this, another person likes. If I am a human being, I will try to know that it is 9, okay? For a machine, it is not that much easy to understand. So because it will understand 9 like this, 9, and it may predict something else. It will say, I don't know, if it is a normal thing. Okay, so how we will train this? This 9, if you take an image of a 9, it is into 28 into 28 pixels, 28 into 28 dimension, and we will have 784 pixels. For example, this is 1 pixel, this is 1 pixel, this is 1 pixel, this is 1 pixel, and here itself we will have more pixels. Pixel 1, pixel 2, pixel 3. Are you following me? I hope you are following this. So you see that 786 pixel inputs are being fed into this. That's why we say we give more inputs, okay? If you have thousands of images, think of that, how many pixels are being sent inside, okay? And you see that the input x1, x2, and 784 inputs are being sent. And we are adding the weights here, okay? And this node has 1, 2, and 3. And we have 1 from here, which is 4 points are being added. Actually, similarly, this is called a network, okay, hidden layers. And a bias is added. And after that bias is added, it goes to another hidden layer, and this continues. And finally, the output is derived, okay? So we get the output as 9. Actually, if you look into this, this is what finally the output as looks like. You see that until it reaches 9, the desired output, we know that the output is supposed to be in the value of 0 to 9, and the model is trained in such a way that until it reaches an approximation of some value. Sometimes it's failure, actually. It's not that 100% it predicts the value. In few times it predicts, and we need to change the model, or we need to change the approach to solve this problem. Okay. So this is what the example. I think this one is clear. This one gives whatever we have discussed on the high level. This is clear. Am I correct?
Yes, sir. Yes. Clear.
Okay. Okay. And we will go on to the next one. See, the machine learning, if you want, you have a features. Features means the petals and stem, actually that is the features are being fed into this. And the machine identifies and picks that it is oranges, it is apples, it is cherries, and I don't know. It is what is that? It is some fruit. Okay, sorry, strawberry and cherries. Okay, and you see that the features are size, the tomato size, and cherries, and stems are going to be like this. Okay, and assisted by human. So machine learning is always assisted by human, and it is, as I told you in the beginning, it is like a historical data. That is, past data is being calculated and it is being derived. Okay. Whereas in deep learning, you see that we are giving inputs at cherry and strawberry. The neural network learns its own and finally comes up with cherry and strawberries. Okay. Sorry, strawberry and cherries. Okay. We'll call it as some fruits. Okay. It divides that. You ask a kid to 2 years kid to separate from the fruits, apple, oranges, and bananas. So it's similar to that. It learns and predicts that. This is called a deep learning. Okay. Whereas in machine learning, actually, you need an assistance. That's what I gave an example also. Okay. Machine learning you need, but here it is automatically predicts till it reaches the higher accuracy. Okay. And what all that? Now we move on to the types of neural network. Okay. And the types of neural network is artificial neural network, a single perceptron or a neuron can be imagined as a logistic regression. Artificial neural network is a group of multiple perceptron similar to our brain. Okay. ANS is also called feed-forward neural network, where we can use this in a kind of a tabular format, text data and image data. For example, as I told you, we can use it for share and other transactions to predict the company things. Okay. For example, like I told you, for one of the example is inventory management. Okay, there we can use it. And the CNN is convolution neural network. Here, this always images can be used to convolution neural network. That is called the CNN, and input in the form of an image, and we can use the target learning also. The target learning, you keep the term as it is. Probably tomorrow, I think the next session you will have a CNN and RNN practicals. Okay. So you can you have 3 days and you can go and refresh these terminologies and it will be more useful. And then you can practice on this from the 3rd day onwards. I think you will be comfortable. Okay. And in case if you need any help, you can reach out to me also. So RNN is a time series data and audio data. Time series data means which is a continuous data. Okay. For example, audio data is continuously speaking for 15 minutes. You can give that as an input and fix the words actually. And audio text conversion for video. Video also is a time series data. There you can use RNN, recurrent neural networks. Okay. And DL applications, deep learning applications actually. The concept detection, which is going to play a critical role in years to come, in 10 years. Deep learning helps to detect cancerous tumors in the human body. Okay. And the next one is deep learning is used to train robots to perform the human tasks. For example, few banks started using receptionist as a robot. Okay. And chatbots are being replaced by robots. Previously, you used to have 100 people to answer this frequently asked questions. Now, some 70 to 80% of the questions are being answered by the robots, and only 30% of the questions are being forwarded to the telesupporters. Okay, so which is with the help of deep learning. Okay. Because of this data, we get a lot of data and we achieve this with the processing capacity also increased with this GPU, okay, graphical user interface, GUP, and CPU, like the old traditional CPU has challenges, and we used CPU, GPUs, and graphical processing units, which helps us. Okay, so that's why we are able to. That's why this technology is famous for the last 7-8 years, and it started flourishing 15 years from 2005, and gets into the foothold around 2011 to 2015. Okay. Now it is on the peak. Actually, it will reach its peak around 2030. And the next one is distinguish different types of objects, autonomous driving cars, people and road signs and driving without a human intervention. Think of this problem actually when you are not getting a sleep. Think of you are coming up with writing a programming for auto driving cars. How many conditions, millions of conditions you need to apply, and that condition needs to be applied. For example, I will tell some 4 or 5. For when you are driving on a line, if you come across any obstacles like a cow, human, and even for a even for a rabbit also, you need to stop in use. Okay, if you hit that, you will get a penalty, and you are not supposed to hit on the road. Blue color traffic signals you need to follow, traffic rules you need to follow. In few places it is 80 kilometers, few places it is 40 kilometers, and yeah, you are not supposed to follow, even though you have a right to go. If you have an ambulance coming in, you need to stop it. So all this are, do you think it's possible to write a code to solve this problem? But whereas in the deep learning, in the machine learning and AI applications solve this problem with the help of a deep learning. Okay, and Google has tested this autonomous driving solution for 1 million miles actually, millions and millions of miles actually, and in a 10 years from now, we will have this 10 years or 15 years from now, because this is similar to a healthcare application. We need to be very careful. You may think that all driver jobs will go off, but it will have a different flavor of that. Okay. Actually, government needs to plan for this. Machine learning, machine translation, that is sentence and phrase translation. Whoever has watched this ICC World Cup, Google has come up with one advertisement. Some person goes to an Andhra and he saws some kind of words, okay, in a different language. He takes the snapshot and easily identifies it is in English. You can go across the world and you can do this. So that is called machine translation. And the next one is deep neural music composition. We already discussed this, produce this, okay. And the next one is very interesting, and the colorization of images. You fed this black and white images. It introduces that this person is a baby and a girl, and what we need to have is different colors. Okay, the car will have like this. This one will be like this, and this is the cat toy, and the toy color, which is an colorization using a deep learning. Okay, so these are all the different objects. You think of that, how to train this, validate and implement this. Okay, and the next one, these are all the applications of deep learning, and the limitations of deep learning is data. Okay, if you have the more data, then the prediction is going to be more accurate. Okay, and and if you have the volume of data, and this is the prediction. Okay, if you have a less data, it is very difficult to learn and give the proper output. And the next one is the computational power. computational power means, for example, with the CPU, it is a batch processing kind of a thing. And a GPU, see, some of you have given your kids with Windows Xbox. If they are playing games in the computer, then you need to have a special processing. So, which is similar to that graphical processing unit, okay, which costs more, but that is one of the deep learning requirements, which is having a limitation because you need to spend some little bit of extra money. And the third one is time. The training time is more compared to the machine learning model. Here it may take days, months, and weeks and months also. So because of the volume of the data, and after 4 or 5 days, it may crash. You are not getting the expected results. Then you may go on to the retrain this. Okay, so that's why it is trained. Once you train and you have the weights and bias associated to it, and you can use it everywhere. Okay, so that is the objective of this. We'll see that examples also. And artificial intelligence evaluation is how it started in 1950s. Early artificial intelligence with small things, okay, and machine learning is started in 1980s, and there were some silence actually. They're not much picked up, okay. Actually, in 2010 only, the deep learning gets into the breath because of start using small phones and web technologies in a massive. Then that leads to the large amount of data. When we have the large amount of data, like a big data, the need for coming up with a new model has come up, which is called a neural network. The neural network concept itself is already there in 1980s itself. Okay, I have not given this history. If you Google it, you may have it. Okay, and over a period of 10 to 15 years, deep learning is going to play a key role, and it is going to be part of our life. Okay, you accept it or not, it will be in our life. Not deep learning. It is artificial intelligence is going to be that. Artificial intelligence is the outcome of an automated solution resembles the human intelligence. Okay. The next one is what are the deep learning frameworks? The first three are the key. Actually, this course talks about Python, TensorFlow and Keras and PyTorch. TensorFlow and Keras goes together, and PyTorch. You can use this framework and start exploring your things. Okay. And there are also Caffe and Deep Learning 4J and Microsoft Cognitive Toolkit. But the famous one are the first three are the famous ones. So famous one means largely used. Like what I have said for activation function relay is used. Similarly, for error cost optimization, we are using mean square method. Similarly, for this deep learning, TensorFlow, Keras, and PyTorch, we have abundant materials available, and we have a support also. Okay. Next, we will move on to the deep learning pre-trained model. Actually, here only we are coming into that. I will take 5 minutes to explain this, and then I'll take questions. Simply put, a trained model, pre-trained model in a model created by someone else to solve a similar problem. Instead of building a model from scratch to solve a similar problem, you use the model trained by another problem or a person as a starting point. For example, if you want to build a self-learning car, or some examples for image recognition, cat, lizard, or something. Okay, so I use this actually. Please tell me, are you able to see this? Hello?
Yes, sir. Yes.
Okay. Here, what I'm going to see, I'm going to use a mobile net with Keras. Okay, are you able to see this? Mobile net with Keras. This is already a trained model, mobile net V2 model, which is trained. The first we need to import, it says that we need to import all this, sorry. we need to import all this packages, like what we do it in C. Okay, so we need to import all these packages. That are, just now I told you, the framework, the Keras and TensorFlows, everything is there. TensorFlow is on the top and Keras is on the back end, and which goes together. Okay, if it is a PyTorch, then you need to use different import libraries. Okay, once you use this, the second step is, are you going to run this on a GPU or a CPU? If you are going to use a GPU, then you need to use this piece of a code. Okay, and finally it will say it is available. If GPU is not available, then you need to procure it. Okay, so that leads to an extra cost. But in Google, there are some free availables. You can use Google Colab. Okay, and the next one is, this is what the interesting point is. First, we make a call. Actually, what it's saying is, I think better you can, first we make a call, tensorflow.keras.application mobilenet.mobilenet to obtain a copy of a single pre-trained mobile net with weights that were saved from being trained on an image net. Okay, we are accessing this module. We are assigning this module to a variable called mobile. So this is what the code. So what it says, which is a single pre-trained mobile net with weights and bias. Just now I told you the weights and bias, which is a pre-trained one, and we are assigning this to a mobile variable. So the features, the trained model is downloaded now. The next, what you need to do, you need to know, you need to give an input as an image, and you need to do a pre-processing. Suppose if you give, so for example, if you have buy a ready-made shirt, 90% of the cases it will work as you can wear it. Few percent will go to a tailor and change it because they are very peculiar on the attire look and feel. Okay, so in this case, what they will do, the positioning and other things. Okay, so here you see we are defining a function. Okay, that's why I told you, if you know what is a function, how to write a function, you can write this piece of a code and understand it. Here we are giving the image path. My image resides in this path, or you can give some server path. If it is a server path, you need to know how to give this. That's all. And what is the dimension here? The target size is so and so. It is 224 into 224. That is the matrix dimension. Okay, it is 224 into 224. That many inputs are going. And finally, it is a say this thing as pre-process this. Okay, and once it is pre-processed, then we will go on to this. See, the pre-process function image load, which accepts the image file and the target size of the image, which we are setting as 224 into 224, which is an actual default size for a mobile net. Mobile set looks for a default size. You can give lesser than that also. Returns an instance of a PIL image. PIL is Python image library. Okay, there are some tools available to convert that to a normal image. So then converting that image to a normal image, and finally what happens, the pre-processed image, and we can, suppose for lastly we call a pre-processed input from the mobile net, which pre-process the given image data to be of the same format as the image in the mobile net was and originally trained. Specifically, the scaling of the pixels image between -1 to +1, and this function returns a pre-processed image as a NumPy array. It is it always gives an array of value in the numbers only, that is -0 to 1, and this results in the overall image as a prepare image function, and this is the final output. Okay, so here you see that the example. Okay, predicting the mobile net. Actually, we have only 4 steps. import, and are you going to use GPU, or going to use download the mobile net pre-trained weights and bias, and use this where your image is there and pre-process it. And once this pre-process it, you load the images and convert these images and prepare the images finally. Okay, the same code is used here actually. For example, once that step is done, you see this. This is the image file path. The image looks like this. Okay, and what happens? We are going to process the image by passing a prepare image function and assign the result to a pre-processed image. We are then having a mobile net to predict the image by calling predict. Okay, you see that this is what we are doing. Then the results are being used by this statement. We are going to get this. So the final result is this. It says American chameleon, okay, which is 58%. So which has the higher frequency, higher percentage. The next one is green lizard is 27%, but this actually is American, okay, which is this one is the real one. Similarly, the same code is used, and we are giving this as an input. And you see this pre-processed image. These are all the 3 images, and you see the output is, which is an espresso coffee, which has the accuracy of 98%. Okay. See, even though I explained to you for the last 90 minutes, you heard different terminologies of hard terminologies, but the way of implementation of pre-trained models is possible. Actually, you can go and search for a pre-trained model and you can use it. Once you are familiar with the pre-trained model, go and you create your own model and train it. Train, validate, and test, train, test, validate, and then reuse it. So this is what, how simple you can get familiarized with machine learning and deep learning, and you can come up with your own AI application. Similarly for the strawberry. So here I am showing a trained model which I am downloading. Okay. So this is what the overall. I think you are able to understand what I am trying to say. Okay. The next one is finally a recap of 1 minute. AI enables machine to think, and we have gone through machine learning, supervised and unsupervised reinforcement. Machine learning is a statistical tool to explore data and analyze. And you see that deep learning is multi-neural network, which has ANN, artificial neural network, convolution neural network, and the recurrent neural network. And over that, you have a data science, which has a statistical property, linear regression, and others, and big data. Linear regression, others means Euclidean and others they choose to see. Okay, so a lot of things comes into data science, and big data also plays a key role. So the final recap of whatever we have seen just now in the 90 minutes, this is a recap of at the very high level, at 2000 feet level. Okay, I think I am done with this. If you have any questions, you can send a mail to me, and any questions and answers, I can go and take some questions. Okay. If you have any questions, let me know. Team.
So in the ANN, you have used the activation function, then you have used the cost function. So what is that the cost function is used for that one?
The cost function is, for example, see, you have errors now. Suppose, for example, you have a cat and you have a cat and dog, okay? You fed as an input, but you are not finally getting a cat and dog as an input. For example, I will show you one more example here, okay? See this is the image, okay? So suppose, for example, you are going to identify this elephant, okay? And the output, what we got is this one. So the error, we have an error, okay? With this error, is called a cost function here. Suppose the errors are always negative, okay? So that's why we find the mean square of that. So which is made as a positive and then fed into the system. It's a reverse backward propagation. And finally it rains and finally comes up like this as an elephant. Okay, so that is that cost function we are using. We call it as a cost function, which is an error.
Okay. After
Error
finding
in
out,
the
after finding out, again
prediction.
we are back propagating it to the system.
Yeah, I think don't get afraid of the terms whatever I used. You may learn more terms, but it is easy actually. You can learn on your own, like a self-driving car. You can learn on your own what is the material available in the net. I think it's very, very easy, okay? But you need to, as I told you in the first slide, what you need to think is uh, you need to have interest in deep learning, knowledge on one programming language, commitment to learn. You need to have a commitment to learn. And the third one is little knowledge on machine learning. If you are deep into machine learning, I think you will ask too many questions, okay? Yeah, even when I check with my friends, he will say that you are asking too many questions. When the model is, when the model takes care of everything, even though I told the hidden layers, okay. So even here I told some of the layers. All these are automatically trained. Why you are explaining this? See, it is not a hidden box. You need to know why. Suppose if there is any issues, how you will solve this. So that's why what we are doing when I start using MobileNet V2, this is already pre-trained and weights and wires are being already added. Suppose if I want to train new MobileNet, I need to know how to train that. So that is required. Okay. I don't.
Yes, sir.
Any other questions?
Any other questions from participant side?
Sir, I use CNN for image classification, the multi-classification project. So, and I'm not trying to use a particle swarm optimization, but I'm getting some error message. Actually, I implemented it on MATLAB. So I don't know if you can guide me, sir.
What is it, sir? Sir, the second part, will you please explain?
I said I use I did multi-classification of images. So and using CNN. So and I want to optimize using particle swarm optimization techniques and get the model evaluated, getting the accuracy and all other evaluation parameter, evaluation metrics value. So, but I'm getting some error.
So you use all the parameters. Parameters. What is that dimension you are using, sir?
227 by 227 by 3.
You look into that the model actually. What model? CNN model actually. Which particular thing you are using, like MobileNet? Are you using any pre-trained model, or you are going to train your model? See, what you can do actually, you have a session on Tuesday and Tuesday. First two session, one on CNN and another one on RNN. So if it is not addressed in that, if you still have some doubts, you can mail me, okay? Not an issue. I will help you. Okay?
Okay, sir. Please kindly share your email, please.
Yeah, I think I already showed this actually. It is here.
I cannot see it from there. Please share through the chat box, please.
What is that?
Please share through the chat box, please.
Okay.
Thank you, sir.
Any other questions, team?
Any
I
other
think
questions
actually,
from participants? Yes.
I don't know whether you got it or you were keeping silent actually, but it is easy and you need to take it to the next level. Okay? So,
Hello?
Participants, if you have any doubt.
Hello? Hello, ma'am?
Yes, ma'am.
Yeah, I just wanted to ask a question. Sir,
Okay.
actually, I am interested in implementing deep learning approach for multispectral data, and I need little training for that. Can you suggest some resources, and can you suggest some algorithms to implement? I want to do classification of satellite images.
multispectral means what kind of input?
Satellite images. Satellite images, sir.
Satellite images, which is similar to a medical imaging. No?
Yeah.
I think you can go for CNN model.
CNN model.
And CNN model,
Some
and what you can do, you start with a lightweight model. If you're not able to get some desired outputs, go for a custom trained model. Okay.
how do I do that, sir? Any resources for that customized models?
I will forward that. Okay, I'll forward. You can send me a mail. I'll forward that. Okay. There are you can start with mobile net. Just now I showed you, no, that one. You can use that one also, or you can search for on the Google the pre-trained model and start using that, because the image medical imaging data is used for CNN is the best model, and you can go for it. Okay. And when you are using it, actually, whatever the parameters I have, whatever the points I have highlighted, you need to use it. Okay. For example, when you have an image, the image will come at different size. Okay. First, you need to format the image. For example, for the previous question also, this is the answer. If the image is not in a proper format, for example, Google Net expects into 256 into 256. If it is beyond that size, actually, it won't recognize it. Okay, the desired output will be different, or the percentage of output will be accuracy is reduced. Similarly, you need to format your input, and then you give that dimension data, and then there is one approach called you are going to use the approach called push or pull or min or max actually approach. Okay, that approach you need to change. Then you need to train your data. Okay. I think this pull or push, I have not used it in this training because that is not my objective of this training. Probably on the Monday, Monday class, I think that person will handle it. Okay. The pooling is nothing but actually, I think we have a time now for 5 minutes.
Yes, sir, you
swap,
can take it.
they call it as a swap. Okay. You have an image like this. And for example, I will take the image from my number 9. Okay. Here I take here I take number 9. Okay. What happens? I will take this 3. That is called a 3 into 3. Okay. And then if I take this 3 into 3, how this one works, actually, that's what I'm explaining. Okay. You don't get, see. I'm taking this 3 and overlapping with the next one. Okay. Swap is another method. I'm overlapping here. It is null. The values will be 0. Here I am overlapping. Here I am overlapping. Okay. Here I will have partly null and partly weighted average. Here you have a different colors and the weights will be different. So that's why it's called, it will go left to right, right? Or it is a kind of a matrix multiplication, okay? And this is being repeated. Now, if you go with the swap approach, then this one is called a, and you can go for a, see, this matrix will give one output, okay? For a 3 into 3 matrix will give a 3 into 3 output. In this 3 into 3 output, you can go and take a value of min and try to come up with some solution. If it is not reached a desired solution, then you can come up with a max value or an average value. I think all this will be discussed in our next meeting, which will give you a comfort level. In case if you still have some challenges, you can drop me a mail. Okay, so I can help.
Thank you, sir. Thank you.
Okay, any other questions? It is interesting. There are a lot of videos available on different languages. You can go through that. For image processing, definitely CNN is the best model. But why I told you to go for a pre-trained model is you feel some happy and then you can learn and then implement that. It is kind of a backtracking, okay? Back propagation, what you are going to do is, okay, that is not the right approach. But if you are confident on next class and next class, next two classes, then you can go from the scratch, okay? Even though there are a lot of terminologies used in this session, actually. Okay, that's all from my side. Any other questions?
So one of the participants asked you to suggest any good self-learning course for this. In chat box, they have posted one question that can you suggest any good self-learning course for that, sir?
No, if you have a lot of money, then you can go for Edureka or some other learning. If you are from a poor background, YouTube is the best place to learn everything. And you guys can send me a mail and I can suggest you based on my availability. Okay? So that is one thing. So
okay,
it is possible actually. And if you have a lot of money to spend, Great Lakes is there and a lot of things are there. And or you can take a specialization course in data science. It ranges from 5,000 to 3.5 lakhs. There are a lot of things are there. So my best suggestion is you have interest to learn and learn from YouTube with the approaches what I explained. Actually, I explained line by line actually in the sequence only, so that you won't miss anything. Maybe one or two things I missed over a period of time. You will learn your things. Okay. Okay. Anything else?
One side.
Hope
they're asking you to share the lecture PPT, sir. Sure,
I'll do that. Okay, I will forward to the professor, and then you can take it up. Okay, and thank you for your thank you to everyone. And
that was an outstanding session, sir. Thank you, sir.